In this video, we are going to have few project topics in mathematics at UG as well as PG level. Now, what are the main steps to do a project? We need to have branch and topic selection, literature review, documentation. Now, in branch and topic selection, that what we need to do, choose a branch, that is area of mathematics that genuinely interests you. So, as for area or branches of mathematics are concerned, you have algebra, calculus, geometry, real analysis, complex analysis, topology, graph theory, fuzzy mathematics, and so on. And in that you have topics, say for algebra, abstract algebra, or in linear algebra that you can do. And in abstract algebra, you can concentrate either on groups or rings or fields and so on. So then in that you can narrow down to your either groups or rings, and there also one particular topic can be chosen, subtopic can be chosen, and you can explore on it. Similarly, in the case of calculus, geometry, and other branches also. So first branch, and then topic, then subtopic, and then go to your particular title that is suitable for your project and work on it. So that is in the case of branch and topic selection, first step that we have in this. Now you have to ensure if it is appropriate for an undergraduate or at postgraduate as a postgraduate project. Then you have to choose a topic, the specific area as mentioned earlier within these branches, but that should have practical applications or rich in examples. Then the topic, if nothing works, you have to contact your project advisor to get a topic from any of the branches. Next comes literature review. So you can look at various textbooks, research papers, search in Google, or search in Shodh Ganga, a reservoir of thesis. So that you can have. So you can start with the literature review to understand the current state of knowledge in your chosen topic. So these will help you in that. And then comes the final part, the documentation. You have to prepare your findings in a clear and organized manner. You should include a comprehensive explanation of your topic, methods, results, and conclusions. So as for documentation is concerned, as an example, suppose your interest is in recreational mathematics, and you want to say what is the role of recreational activities in learning mathematics effectively, and you can give a title for your project in this way. Your project should have abstract, list of tables and figures, introduction and preliminaries. Then the rest depends on the topic that you choose. So in this mathematics and arts, arts and puzzles, games, they are discussed. So in that freeze pattern, modulo art, Desmas art, and this particular one, the cross and the crescent puzzle, which is given in mathematics can be fun by Perelman in that book that's given, and linear algebra in computer graphics and games. So all this is for as a sample that's given, but you can even just concentrate on arts alone, discuss in depth wallpaper group, and then freeze patterns. So that can be discussed. So it's up to you, your interest. It depends on your interest. And you can also give some interesting applications of mathematics, how subgroup can be determined. Okay, from the it is in the particular case of group of symmetries of a square that's considered in this case. So the aesthetically you can have the subgroups when you consider with the help of a motive. If you do it, the subgroups only will give you an aesthetic design. The other combinations, because see in when you consider the group of symmetries of a square, you have actually 8 elements. So that it has got 8 subgroups, not any other combinations. Actually 2 power 8 subsets you will have, not all of them will be subgroups. There are only 8 proper subgroups. So how that can be explained using a design. So like that and all you can discuss. And then this one is determination of the real main character in Shakespearean tragedies using graph theory, and how to find the time of murder using differential equations. So these are some of the interesting applications of mathematics. So they can be included. How you can effectively study mathematics with the help of recreational maths. And then you need to conclude, and you have to give references also. So that's as far documentation is concerned. Now we'll go to the project topics, some of the project topics at UG level. You can investigate the properties of prime numbers and explore the distribution in the number system. You can investigate the applications of differential equations in science and engineering. Or you can have, you can analyze the properties of geometric shapes and explore the relationship among different shapes. Investigate the properties of different types of functions such as exponential, logarithmic, and trigonometric functions and their applications in various fields. Can explore Zn, the congruence classes modulo n. You know pretty well that under addition modulo n it forms a group. So in that the group properties can be verified in the case of Zn for various values of n that can be listed. The properties, some of the known properties for that illustration, and the theorems, explanation for the theorem or illustration for the theorems with the help of Zn. So all that can be particularly discussed. The one mainly which you find to be very tough to understand as such. So for them and all you can make use of Zn under addition modulo n it forms a group. So here a few are mentioned, the orders of elements, subgroups, and even here homomorphism can be included. And as a ring, when you visualize your Zn under addition modulo n, multiplication modulo n, ideals, homomorphisms, direct products, all of them can be discussed. You can explore on Sn also, the symmetric group of degree n. So in that, which forms a group under composition of mappings Sn. Various group properties, subgroups, orders of elements, Landau's function, homomorphism, they can be explored on Sn. And Un, you can that can also be explored. Un, the collection of units in Zn under multiplication modulo n, and an exploration on An will be another topic. Then an exploration on number sequences, OEIS, the online encyclopedia of integer sequences, will definitely help you in exploring number sequences. Then various subtopics in group theory can be explored with various groups. Various subtopics in ring theory can be considered, and you can explore them with various rings. You can prepare a question bank with solutions and of course explanations from various competitive examinations on a particular field of mathematics. Suppose you consider algebra, in that abstract algebra, then what are all the problems that have been that have come in abstract algebra, and particularly say in the case of groups or rings, or in both in fields. So like that you can collect, you can have a question bank. See, as such question papers, whether you go for NET, SLET, or IIT JAM, so you will have a mixture of in the question paper as such will have a mixture of all the topics, but you choose one particular topic. It can be on real analysis, it can be on algebra. So you choose your particular topic. In that you start collecting from various competitive examinations. That will be an interesting project and useful project also for you and for your juniors too. And then recreational mathematics, again if you have got creativity. This can be your choice. Recreational mathematics, mathematical art, mathematics in puzzles and games. So in that, if you can again the same uh, page, this design is created with the help of Z4, that is called modulo art, and again with the help of this design is created, and this also is created. Again, in Max Can Be Fun by Perlman, in that book, you would have seen this puzzle to show that the area of crescent is equivalent to area of cross. So you can give geometric explanation for that, as well as the algebraic part of it. So that is a nice puzzle to discuss with. And the um, square grid, what we had with this design, you can vary the designs, and you can design your saris also, or salwar, whatever it is. So that is another interesting part of recreation mathematics. And you can create cartoon pictures using various equations of curves, that can be done with the software Desmas. So you have these as under recreation mathematics. You can also have dynamic project with the help of GeoGebra or Desmas. For example, if you consider as a dynamic project, this one in which if you want to say that if pole lies inside the ellipse, where will be the polar? If it lies on the ellipse, where that polar be? And outside means where will be the polar? All this you have studied in analytical geometry, but how we can give it as a dynamic, how to visualize that? So that can be done with the help of GeoGebra. So here is an example. So when the point lies inside the ellipse, the polar lies outside. When the point lies on the ellipse, it becomes tangent, and when it lies outside, the polar lies inside. So the pole lies outside and polar is this. So you have you can have this dynamic project not only for this alone. You can have there are various locus problems that are discussed in analytical geometry. All of them can be done as a dynamic project using GeoGebra. And the dynamic project using Desmos, that can also be explored. And as a simple one, using polar curves, you can create a design like
கவிதையே தெரியுமா என் கனவு நீதான்.
So these are dynamic projects using GeoGebra and Desmos. Now we'll have few project topics in real analysis. You can explore your Cantor set, convergence of sequences and series, metric spaces and continuity, basic topology of the real line, compactness and connectedness, compactness and continuity, sequences in real analysis, complex analysis, sequences and series of real numbers, complex numbers, functions. Then you have project topics in operations research as project management and optimization, facility location problem, game theory applications, risk analysis and management, healthcare operations, supply chain optimization, inventory management, scheduling and timetabling, transportation network design, queuing theory applications, decision analysis, and that will be an interesting one, energy management, network optimization. So all of these projects will be project topics will be an interesting one in operations research. Any one of them can be chosen, and there are lot more in operations research. Only very few are mentioned here. Then in mathematical statistics, we can have hypothesis testing. Very interesting one again. With the help of questionnaire, this can be discussed. Then ANOVA, analysis of variance, statistical methods to economic data for modeling and forecasting, environmental statistics, analyze genetic data using statistical methods, central limit theorem using sample data. Then in graph theory, you have for various classes of graphs the following topics. So that can be studied: graph labeling, coloring, domination, energy, connectivity, graph isomorphism, graph matchings, graph algorithms. So all these can be explored, and again there are a lot of other topics too. Very few we have mentioned here. Next, we have few topics on uh, project topics in at PG level. In algebra, you can have finite fields and rings in the development of error correcting codes, interaction between elements of a ring, theory of ideals in commutative rings, including prime and maximal ideals, and their applications in algebraic geometry and number theory. Apply the Chinese remainder theorem in the context of ring theory, especially for solving systems of congruences. You can explore the concept of valuation rings, specific families of simple groups and their properties, matrix factorizations, especially in singular value decomposition. This would be very useful. Knot theory can be studied. Automorphism groups of various algebraic structures such as fields, groups, and graphs, and their role in understanding symmetries. Applications of singular value decomposition, the properties of Noetherian rings and modules. So all these topics can be explored in algebra. Then in real analysis, you have functions of bounded variation and total variation, applications in differential equations, summability methods, sequences and series in measure theory, sequences and series in probability theory, Lebesgue measure and integration, compactness and connectedness in Euclidean spaces, compactness in the real line, metric spaces, topological spaces, function spaces, Euclidean spaces, product spaces, and normed spaces. In graph theory at PG level, you can again study graph labeling, coloring, domination, energy, etc. at advanced level. Planar graphs can be studied, graph embeddings, trees and spanning trees, Eulerian and Hamiltonian graphs, graph algorithms, social network analysis, graph pebbling, graph burning, spectral graph theory, applications of graph isomorphism in chemistry and computer science. Then in the case of algebraic graph theory, we have a list of few algebraic graphs: Cayley graph of a finite group, zero divisor graph of a commutative ring, prime graph of a ring, total graph of a ring, co-zero divisor graphs of a ring, annihilator graph, unit graph of Zn, zero annihilator graph, co-maximal graph, the order graphs of groups. These are very few topics that are mentioned here under algebraic graphs. You can also have graph theory and adjacency matrices as one of the topic. Key properties of zero divisors graph. Divisor graphs for sets of integers or algebraic structures like polynomial rings. Applications of divisor graphs in solving number theoretic problems and integer factorization. Zero divisor graph of Zn. Zero divisor graph of Zn of x, that collection of polynomials over Zn. Comparison of zero divisor graphs in various rings. Relationship between the chromatic number of this zero divisor graph of Zn and the factorization of n. Zero divisor graphs and ideal theory. The zero divisor graph for the ring of upper triangular matrices over Zn. Then in fuzzy mathematics, you have actually fuzzy set, intuitionistic fuzzy. These are just generalization of this one, or by imposing various conditions on the given set. You have a lot of other fuzzy sets like intuitionistic bipolar, Hessian, L fuzzy, Pythagorean, fuzzy soft sets, spherical fuzzy sets, and so on. So you can apply them on algebraic structures to get results in fuzzy algebraic structures, and fuzzy graphs, fuzzy operations research, and neutral-suffix sets also. Now these are useful links um, to carry out your project. And again, we have mentioned only very few. First one is this. In this you will have certain groups with their properties, and then in the case of ring also you have then Shodh Ganga, that reservoir of thesis. So that is given by this website address, and GeoGebra, very interesting one for the dynamic project, and Symbol Lab. Suppose you have to find orthonormal basis for given R3 with just basis in minutes, few minutes, or rather few seconds, you can have the answer for that. So for that and all, Symbol Lab as well as this wolframalpha.com, both the sites will be very useful. Now, with the strong work ethic and passion for mathematics, you can successfully complete an undergraduate or postgraduate mathematics project. So, take your positive spirit with you on your project journey. Never let anything get you down. And best wishes and luck for your beautiful project. Thank you.